All right, let's start. Project network. Now, what I'm going to do today is actually show you how to construct one. We started off by analyzing the project network, analyzing the earliest start time and the latest start time, the critical path and the slack time. Now, what we need to do is know how to actually construct one of these. All right. You know that the edges or the arcs represent the projects and the duration. And the vertices are sort of like the connection. All right? So you must be able to construct a project network. You should know, just recall what a project network is, and you're going to think about, now, before we have the network, we are going to analyze what you call a precedence table. All right? A precedence table, it's what I'm going to show you in a few minutes, which is in your handout. I'll talk to you about it after just recalling what a project network. All right? So for project network, each activity is represented by an H. All right? And labeled using a letter, and the time is marked on the line. And it is possible to move along the network from the start to the end, only in the direction of the arrow. All right? The vertex or the node shown by a circle only represent the event for the start and the end of a particular activity. It's like a connection point. All right. Now, what we need to know is, how do we analyze a precedence table? It is actually also known as a dependent table. It will actually help to plan the project efficiently. Now, what is in the table is actually the task. All the tasks that's required in the project. All right? And you have the task, you actually have the duration. And what is the precedent, immediate predecessor of a project, or what is dependent of a project before you can start. So something like this, activity A, if A is the very first task that you need to do, it depends on nothing. So you don't actually have any dependent, and there's no predecessor. And then you've got the time. What's the duration? B could be dependent on A, so A is the predecessor of B. This is how you analyze the precedence table. And then the duration, and so on and so forth. All right? So let's have a look at one. Let's look at this. How do we analyze example 1? So here you've got to think about, we could break down the project from activity A, B, C, D, E, F, and G. All right? I interchange between activities and tasks. All right? It could be task A, task B, or could be activity A to G. All right? Now, A and B, in this case, you can see that there's no immediate predecessors. What it is telling me that this is the start, that is, they don't have anything to stop them from happening. They can start on day 1 or the time 0. All right? So that is why A and B has no immediate predecessors. When you read a table, a precedent table or dependent table, look at what the immediate predecessor is. There's nothing. So A and B is the start. Now, here, both C and D can only be started once A have been completed. Look at that. C and D. What is the immediate predecessor? A. So therefore, you know that A is immediate predecessor to C and D. They cannot start until A is completed. Now, look at E. E cannot be started until B has been completed. And then F cannot be started until C and E has been completed. So you can see that it goes from one to the other. You could follow, this is sort of like an arrow from A and then to C. And then C is a predecessor to E. All right? Oh, sorry, not C is a predecessor to F. My fault, wrong one. all right? And E is a predecessor to F. And then you know that B has to be C and D. A also is a predecessor of D. So you can see from there how you could more or less line up your project network from the top to the bottom. All right, which line you could follow. And finally, if you look at something like G, the predecessor is D and F. Now, what happened is, from here, is G is a predecessor to anything? So what is that indicating to you? It's the last one. All right. So now the focus question is, how do we actually change this table, the precedent table, into the project network? All right. Let's start. You draw it on your, follow me and draw it on your exercise book, please. So using this table, we know that A and B, all right, they can start at the same time. So we start off with a circle. That is a start. All right? And we draw A and B. They can start at the same time. A3 and B2. All right? So when it is done, have a look at the next, which is C and D. C, you know that you have to continue on from A. So it's that bit here. The network will be formed here. All right, C and D. Now, if I draw C and D this way, do you think it works? Maybe yes, maybe not. Let's have a look. So if you draw B, after B is E. All right? So we could draw E out, but then C has to connect to C and E. It's the predecessor of F. D is not. So perhaps it is better to switch both of them around. All right? Switch both of them around so that you see that you can connect C and E to F. All right? So sometimes when you have a situation like this, I would actually use a pencil first and then rub it off and fill it in to make sure that you can draw the network properly. So C and D both dependent on A. Activity is dependent on activity D only. So you know there's one that's dependent on two activities, C and E. So therefore, perhaps if you plot C over there, you don't really want the arrow to cross. So you actually have to switch it around. And then F, D and F will have to, they are both predecessors of G. All right? And then G to the end. That's how you do it. Think about step by step, logical step. Now, of course, when you actually start working, if you're actually into project management, there are software which could help you with drawing all this. And it's really useful when you're actually doing project management. I've used it quite a bit. Now, let's have a look at this. Can we actually then analyze what is the critical path? Try that, please, everyone. Work on the critical path. Can you analyze? Do a forward scan and a backward scan. I've worked out my critical path. And the earliest finishing, the minimum completion time is 13.5. Did you all get the same thing? Or you're still working on it? So the forward scan is to determine the earliest start time for everything. So the earliest start time for what I get is 13.5. The way I did it was, I start off with this bit, looking at A3 and B2. So I know A completes in 3 hours or 3 days, so it's up there 3, and B 2 days or 2 hours, B2. Now then I come to this node here. Here plus 3.5 is 6.5, 2 plus 3 is 5. So you pick the higher one, which is 6.5. That's the earliest start time for project M. For D, you can see that 3 plus 2.5 is 5.5, where 6.5 plus 5 is 11.5. 11.5 hours or 11.5 days. So you've got to pick the highest one, and then add together will give you your minimum completion time. Alright? So then from here, now the minimum completion time is assume that there's no delay or anything. So sometimes question will ask you if there's a delay in one of them, how would it affect the minimum completion time? From there, minimum completion time, I'm going to work backwards scan. 13.5 minus 2, because there's one arrow going back, so that is pretty straightforward. That take away that, that'll give you this, which is 11.5. Now, coming down here, 11.5 minus 5, 6.5, also one arrow. There are two arrows going backwards there, so you need to work out the smallest amount. 11, the least amount. 11.5 minus 2.5 is 7. 6.5 minus 3.5 is 3. Therefore, you pick the minimum amount, and that will be there. 3 minus 3 will be 0. Here, coming back, 6.5 minus 3 is 3.5. So therefore, that's a critical path. There's no slack at all for that. For those 4 projects, A, C, F, and G. The 4 tasks got to be completed. There's no slack. Whereas those 3, there's some sort of slack time. Alright? Now, let's have a look at this. Can you try example 2, please? Try example 2 and see what you can do. Everyone try example 2. You know that the activity starts off with A and B.
I want to set a time on for lunch. So that,
Alright, okay.
but now he was calling me on the way to make sure.
I hope you get the last events.
I was. That's the year. Oh, I did.
It's still in your bag. Somebody will find it.
Yeah. Somebody will find it eventually.
Somebody will find it.
Yeah.
So think about what is the predecessor.
But look at me.
I mean, really, to be honest, when I started working, when I started doing project management, I actually have software to help me out. So it actually makes life a lot easier. But you must be able to draw.
Did you find it? He had it the whole time.
All right, all right. You can see that C and D is actually depending on A, E and F is dependent on D, B. Generally, up to here is pretty straightforward. Then going further, it's going to be, you got to do it, take it step by step. And again, this is a lot of practice. Doing it today is good because you don't see me tomorrow. You've got time to do your do a few more exercises on constructing a project network. And then Friday we'll talk about dummy variable. That's fine, that's fine. That's okay, that's the first time you're doing it by yourself. So in the exam itself, if you use pencil, then it's wrapping up. Yeah. That's fine. I mean, I start mine up quite a bit as well. Normally when I draw it, I sketch it first and then draw it properly.
Yeah, it's easy to mess up.
Oh, very easy.
Yeah.
It's really easy to mess up this one. So this is what I did. Of course, I planned it really well. And I actually drew it very on a piece of paper first before I did that. So you can see that we start off with A and B. All right. It doesn't matter if you have B on top and A at the bottom. Really doesn't matter as long as it's clear. You should be able to draw draw a conclusion from the table how it progresses. You know that the last one is L. All right. A and B will be the start. L will be the end. Okay. And then what is in the middle? That is the how you decipher the table. So you know A and B. From there, from one of the first node, the start node, you branch out to two arrows, two nodes there. Then, now A is related to C and D. All right, it's a predecessor. So you know from A there should be two branches up, C and D. It's matter whether D is on top or D at the bottom. C is at the bottom. Which arrow? It doesn't really matter as long as you try not to cross any arrows. So let's have a look at the next one. You know after B is E and F. Now, looking at G, H and I, you know I, the predecessor in C and E. So therefore, you really need to have C and E close together. Right? So C and E close together, you have it sort of inside the two arrows, which is one, that below this arrow, this above that arrow, so you can connect that through to that node. And you've got your I. And I is before K. Alright, I is predecessor of K. And J, predecessor of K. And G is predecessor of K. So that's how you realize that your F and D has to be that arrows. And then 3 arrows going into K. And then 2 arrows going into this node. And then L is the last one. It's trial and error. Like I say, it's always good if you use a pencil to do it first. Or sketch it and then draw it properly. So it's a lot of practice that you need to do, and there will be questions asking you to draw your network and then do your analysis. What is the critical path? Like what I did just now. You would be able to do a critical path analysis on this. Go for a forward scan and and then a backward scan. All right? Now, I want some time to hand back your investigation. Therefore, this is the lesson for the day. Exercises for you to do is in club. All right? So hopefully, I've shown you how to analyze a precedence table, and you should be able to construct a project network from the precedence tables. I will do a few more of these examples on Friday. That will be with a dummy variable.